Hi everyone, let's state the rational zero test or rational roots theorem, which is what the little bird applied to this polynomial over here to figure out the list of candidates of possible rational zeros for this function. Therefore, making it easier for the bird to guess that 2 is a zero, as opposed to say 3 or negative 1/3. So, for the rational zero test, or the rational roots theorem, which is more melodic, let's assume that f of x is a polynomial with only integer coefficients. So all of these a sub I guys must be in z, the set of integers. All these coefficients must be integers. And let's assume the polynomial is written in descending powers. The leading term over here on the left, the constant term over here on the right. And by the way, there will be a non-zero constant term, provided that you factor out the GCF first. Now, in our example, the GCF was 1. But if the GCF is, for example, x or x squared or something like that, then make sure you factor it out first and put that to the side. If x or x squared or so forth is a factor, then that means that 0 itself is a 0. And we're focusing on the other piece, not the GCF. So once you factor out the GCF, this will have a constant term, a naught or a sub 0, which will not be 0. For example, in our f of x example here, we had a positive 2 at the end. If each of the terms had an x in it, then you could factor out at least an x as part of the GCF. So remember, factor out the GCF first, and then we apply the rational roots theorem to the rest. We assume this is nth degree, so a sub n is not 0 here. And what then will form our list of candidates for possible rational zeros? So what will be our candidates? For the possible rational zeros of f. Well, if f of x has rational zeros, they must be in the list of plus or minus p over q candidates, where p is a factor of a naught or a sub 0, the constant term, like 2 here, and q is a factor of a sub n, the leading coefficient, like the 4 here. So our candidates will consist of the list formed by when you take plus or minus factors of the constant term plus or minus factors of the constant term over factors of the leading coefficient. And that's how we get our list in our example. We're going to proceed with this example next time.